Welcome to the first episode of Build Day TV. We're with Alistair Cook talking about AWS. Tell us what we're going to be doing.
Learning about networking on AWS and particularly looking at the basics of VPC. And then later on in this series, we'll look more at how firewalling on AWS works and looking at redundancy and looking at some design best practices, because I'm going to start by covering the basics, but a little bit later on, I'll talk about how you might choose to implement and where there's some decision points about where you use or don't use some of the technologies in here. So this is going to be a series of videos, and they'll all stay nice and small and bite-sized because it's kind of the way I like to consume video.
Okay,
So
perfect.
let's get started by thinking about how networking works for on-premises. Let's start with what we have on-premises, because most of the people who are interested in designing networking on AWS have some understanding of what they have on-premises, and usually it starts with some end device, our laptop sitting on our desk. And that laptop is usually then connected to some sort of network with a bunch of servers behind it, file servers, mail servers. This particular scenario here would be probably in the 1980s, Jeffrey, when it was desktops connecting to a bunch of servers. That would have been late. I'm trying to think when I was deploying this.
Yeah,
probably late 80s
no,
into the 90s.
Yeah, about 90s. That's when the token rings were disappearing and the Ethernets were coming in. Yeah.
Yeah, and you were doing Windows 95 support as that was being rolled out as a huge wave.
Yeah.
And of course, at the back end of that, we saw a lot more Microsoft servers turning up.
Absolutely.
And then as we roll into the first .com bubble, we started to have things that were connected through the internet. And so we would have a DMZ network somewhere and a web server on it that was accessible from the internet. And that's probably getting late 90s into the early noughties as people were deploying these networks on premises. A lot of this principle of having segregated networks and some of them exposed to the internet and some of them only accessible internally, and really importantly, it's not really a DMZ without a bunch of firewalls. This firewalling segregation out, this is how network design fits together. And what we're going to see is that on AWS, you build the same kinds of things. You build DMZs, you build internal networks, and you separate them out. Those same principles that you've been building on premises, you can apply on AWS. You just have to shift some of the thinking around it. One of the big shifts on AWS is that we start with internet connectivity.
Okay.
So rather than having a computer that's on a private network that's connected, most of the time, the thing that's connecting to services on AWS is connected to the internet first. This is some of the real power for AWS, because it means anywhere there's internet, there's access to these services on AWS. The next thing that goes on is that we build out these virtual private clouds, VPC. Now, it's kind of a weird name, because when I hear virtual private cloud, I'm thinking on-premises private cloud. Does that seem kind of logical to you, Jeffrey?
Actually, it does, I think. Yeah.
Yeah, but what VPC is your own private network inside AWS's global network.
So it's a cloud within a cloud.
It is. It is, and it's a virtual cloud, so it's a cloud within a cloud.
A fake cloud within a real cloud. Something like that.
Or a real cloud inside a real cloud. Trying to work out what's logical and what's physical is
it's a science experiment inside of a classroom to go out into the except it's not an experiment, it's not a classroom.
Let's
anyway,
go with what it does.
I'm
so the whole idea, the idea with a VPC is that you're creating your own data center. You're doing your own defined networking inside AWS's networking.
Okay.
And so it's your network, you own it, you define what IP address ranges it uses. And that's one of the first things you have to do as you're setting up a virtual private cloud of VPC on AWS, is you have to choose the overall IP address range for this data center, this VPC.
Okay.
And I've chosen here a nice large IP address range. It's always specified on AWS in what's called CIDR, classless internet domain routing format, where
Say that again? CIDR is what?
Classless internet domain routing.
Okay.
It's a way of describing an IP address range. Now, more commonly, those of us who aren't networking professionals would have seen an IP address and a subnet mask.
Okay.
That fulfills the same function as a CIDR notation. It's just a shorter way of writing the same thing.
Okay.
We can talk in another video about what CIDR ranges are, but they just define a network range. So when we specify a VPC, we choose where it's going to be, where in the world. We can talk about these things called regions. They're just geographically separate areas. Where in the world it's going to be, what IP address range you're going to use, and then what name you want for this VPC.
So
specify.
when you're addressing that, I'm seeing is this the way it shows being addressed? The CIDR dash 10 dot IP address and then a low range, high range.
So the CIDR notation is at the beginning is the network address, so 10.64, and then the 00 there corresponds to that /16. So the /16 says that the first 16 binary bits of the IP address are the same, then it's in this network.
Okay.
So in this case, the 10.64 is the same for all of the subnets inside here.
Okay.
We can talk some more about CIDR ranges in another video because it is just a way of defining a subnet.
All right. Fair enough.
I'm going to try and keep my CIDR ranges reasonably easy to understand, but they aren't the most important thing in this.
All right.
One of the things about a VPC is that things that you often think have to be unique don't have to be unique on a VPC. So in a particular region, for instance, the nearest one to me, which is in Sydney, Australia, for a particular region, there can be multiple VPCs from multiple customers that have the same CIDR range. The network address range is specific to the customer. It can be reused between customers, and in fact, you can even reuse it within customers. I could have two VPCs, both in Sydney, both using the same CIDR range internally.
Okay.
This gives you a lot of copy your production environment to a test environment and use exactly the same IP address ranges. There's some interesting things around this. This is an entirely software-defined networking, and this IP address range here is contained entirely inside your VPC. No requirement for it to be unique for the VPC. The next thing we create inside of VPC is some subnets. Now, we create our own subnets. The subnets also have their own CIDR range, but the range of the subnet has to fit inside the range of the VPC. So we have a very large range for our VPC. In my case, I've chosen a really large range, and then a series of smaller ranges for each of the subnets. Again, we choose what IP address range we want for the subnet. We usually give the subnet a name because on AWS you get lots and lots of objects, and so naming them becomes important. Here, the subnet does need to be unique within a VPC. So I can't have, you can see my pizza public 1 subnet here with a CIDR range of 10.64.1.0. I couldn't have another subnet inside this VPC with 10.64.1.0/24. The actual address range has to be unique within the VPC.
All right.
But if I had another VPC with the same CIDR range, I could have a separate subnet in that other VPC. And so it's unique with it.
Okay. And how many subnets can you have in there?
As many as can fit inside the VPC CIDR range, but we like a smaller number of larger subnets. Each of these subnets has a limited number of IP addresses available, and once you've created the subnet, you can't make it larger.
You can't make it larger?
You cannot change the size of the subnet
Okay.
once it's been created. And that's a general design principle for AWS that we'll see. So we like having a smaller number of subnets. We like having larger subnets. A lot of the things that drive us to have more subnets on premises don't drive us to have more subnets on AWS. And I'll talk particularly when we're talking about firewalling on AWS in a coming episode. I'll talk more about that. But for now, the primary thing that I'm going to talk about is the separation, is whether a particular subnet is accessible directly from the internet and has direct internet access or not. And we'll come to that, but first we've got to attach our VPC to the internet because so far we haven't.
Okay.
What we need to do to make a VPC internet connected is to deploy this thing called an internet gateway. The internet gateway is a managed service delivered by AWS, and it provides inbound and outbound internet connectivity for our VPC. Highly scalable, high performance, unbelievably high potential network throughput. This really is just part of AWS's software-defined network, and it allows huge bandwidth.
So it's totally controlled by AWS. You just basically put it in place, and that's it.
Yeah, so when you deploy an internet gateway, it's a one or two-step process. You name the internet gateway, and you attach it to a VPC. That's it. It's done. Everything else is managed by AWS.
Okay. Is there any reason you would have to change that gateway at all, or?
I haven't seen any reason to change an internet gateway, but you can absolutely detach from an internet gateway from your VPC and attach a new one.
Okay.
Occasionally we see AWS deploying new features that require a new build of something. I haven't seen it for the internet gateway, but I have seen it for the gateway back to your on-premises network.
Okay.
Called the virtual gateway. I've definitely seen scenarios where they say detach your existing gateway and deploy a new one because the new one will have extra features.
Okay.
Haven't seen it for the internet gateway.
So it's not totally hands-free, but it's pretty close to it.
It's possible that you need to replace.
Okay.
But it's not like you need to configure all of the routes to get to the internet on the internet gateway and all of that. You don't have to configure any of the physical side. You just are creating this logical entity, which is an internet gateway.
Okay. Cool.
An important aspect of the internet gateway is that wherever we have public IP addresses, ones that are accessible from the internet, they live on the internet gateway. They never exist inside our VPC. So the internet gateway is allowing inbound connections through those public IP addresses and potentially allowing outbound connectivity from our subnets.
Okay.
So how do we get that outbound connectivity? We do it through things called route tables. And so there is a router for the VPC, and it controls traffic leaving the VPC. The default behavior for a VPC is that everything inside the VPC can reach everything else inside that VPC, but that there is no connectivity outwards. So normally we then set up route tables on our various subnets to control which subnets can get directly to the internet and which have to take an indirect route.
All right.
If we're allowing access out to the internet directly, we're also allowing access back in from the internet, and that's a risk. That makes it a DMZ. So this then is how we define what AWS calls a public subnet versus a private subnet. The route table on a public subnet says, if you don't know how to reach it, go to the internet gateway. So let me show you route tables. Right, public subnet, the default route goes to an internet gateway. This is the definition of a public subnet. This allows both outbound access directly to the internet from the subnet, but also inbound access through the internet gateway. The alternative is what we refer to as a private subnet. Private subnet uses a NAT gateway. So an actual network function that sits inside a public subnet is then used to allow the private subnet to get to the internet.
All right, that's NAT, N-A-T. What is it?
NAT, Network Address Translation.
Okay.
So in the same way that your router that connects you to the internet has a private network that is your internal network, has a public side, which is the internet provider side, that's a NAT gateway. We have the same functionality going on here on AWS as well.
Okay.
And again, it's a managed service provided by AWS. The NAT gateway itself lives in one of your public subnets, and so the NAT gateway can access the internet directly. But we then change the routing table on the private subnet to point to that NAT gateway. So the private subnet then gets outbound access through the NAT gateway to the internet, but nothing coming inwards can pass through that NAT gateway. So nothing from the internet can reach into your private subnets. And this is why we differentiate them out. I talk about public subnets mostly as being a DMZ, because they're exposed to the internet, it's a higher risk place. Whereas private subnets are much more like your internal network, where there is much more protection from the internet. So as examples of how those route tables work, the default route table on a brand new VPC says that the entire VPC CIDR range is local. Now, although we might break out that VPC into a series of subnets, we don't need to set any rules about how you move from one subnet to another. AWS handles that for us. So within a VPC, every subnet can reach every other subnet. Okay. But the default route table says that you cannot get past the VPC. So there's no route to get out, there's no route to get in. There's just that one line that says the entire VPC CIDR is local. If we want to make a subnet public, we will add a line, and it's that 0000 line that goes to an internet gateway. If that, what's sometimes referred to as last resort route, goes to an internet gateway, then we have a public subnet. Right, we didn't need any additional route to reach every subnet inside the VPC, but we have added a route to get to the internet, anywhere we don't know, that goes out through the internet gateway. And because we have a route direct to the internet gateway, that also allows incoming connections back in to our servers inside this public subnet. Behind the public subnets, behind the NAT gateway, we'll have the private subnets. Their route table still has that last resort route, but now instead of going to the internet gateway, it goes to a NAT gateway. So again, don't need any specific routes to reach anything inside the VPC, that's already handled. But we now have an outbound access going to the NAT gateway, but no inbound access. No access from the internet directly into our private subnet. So the default, best practice is not to use that default route table, but to have a specific route table for every subnet.
Okay.
And so then we control, here is a public subnet because I put a route table on it that makes it public. Here is a private subnet because I've got a route table on it that goes to a NAT gateway. Once we've built up this networking, then we start deploying some instances, some servers into it. So we might have a web server that sits in our public subnet that's accessible from the internet. We might have a bunch of back-end servers, the file and mail servers that were on my on-premises example. They live inside the private subnet.
All right.
The web server is the only thing that is exposed to the internet because it lives in a public subnet, while the file and mail servers sit on the private subnet and they're not directly accessible from the internet.
If you had a web, an internal web and an external web, internal would sit on that external. I'm guessing that there's also a way to have like a staging area for your external website so you can test features before it goes public, and then you can push that easily, right?
There's a whole lot of different ways you can build that out. Sometimes that test environment is actually a whole other VPC.
Oh, okay.
That's a copy of your production environment. And it can be a complete copy. You can use the same automation to build out your test environment as you use to build out your production environment and have it as an absolute copy. Or alternatively, you might have a much simpler environment where you're not going to be making any changes. You might have on a private subnet a development web server.
Okay.
You might make your tests on the development web server that lives in the private subnet, isn't accessible to the internet. When you're happy with those changes, you might copy them to the public web server that lives in the public subnet. Absolutely.
Would you have backup subnets too?
Typically not, because backups on AWS, at least the AWS service for backups, uses the underlying storage. So there's a storage service under these EC2 instances, these virtual machines. The storage service is called the Elastic Block Store. And backups are handled by AWS by copying those EBS volumes. So they're done in the storage layer rather than done inside the guest operating system in the EC2 instance.
Okay.
You absolutely can, though, if that doesn't suit your requirements, and it may not, because there's some constraints around how long it takes to recover and the granularity of recovery. So you may run your own backup application inside your EC2 instances, and you might choose to separate that out into multiple subnets. You might have, as you say, a dedicated subnet just for backups. Now, bear in mind that all of this is software-defined network. The usual reason for having a backup network separate from your production network is to separate out the bandwidth, to have the backup traffic going across different physical network adapters from the application traffic. Well, that may not make sense on AWS.
All right.
Inside your VPC, you've got lots and lots of bandwidth. The physical servers under this will typically have 10 gig, 40 gig, or 100 gig Ethernet in them. And so there's a lot more bandwidth available. So you may not choose to separate out because you need more bandwidth. You're more likely to choose to separate out for security concerns. And we'll talk some more about that in the design elements, where we talk about how you design this networking for security and in particular for firewalling. But I think that's a good topic for probably our next episode.
Okay.
But as a basic design principle, we have a VPC with an IP address range that we've chosen. We carve it up into subnets, And EC2 instances, our virtual machines, live inside subnets. We then use the route tables to control how you get to the internet from those subnets. One of the important aspects is getting back into our EC2 instances from the internet. And this uses public IP addresses, just like it does in your DMZ. Most people use AWS's public IP addresses. AWS owns quite a lot of IP address ranges all around the world. But if you own your own IP address ranges, your own public ranges, you can bring those in and continue to use them as you go from on-premises to on AWS. Most people just use AWS's public IPs.
Okay.
When we have a public subnet, there is a policy tick box on that subnet to say, when I start an EC2 instance in the subnet, allocate a public IP address for it and have the NAT gateway do the translation between the public address and the private address. So the EC2 instance itself only knows the IP address on that subnet that you defined. But we can have a public IP address that lives on the internet gateway and have that natted in. So all of the traffic in this case that goes to 202.27.184.3 would actually land on my EC2 instance, whose IP address is 10.64.123.
Okay.
And so the EC2 instance only knows its private address, it doesn't know its public address, but the NAT gateway handles that for us. And you'll see in the next video where I show you actually building this in the AWS console, where that information is available to you in the console. An important thing to understand is that that IP address by default is allocated to the EC2 instance when it starts, and then is deallocated, returned to the AWS pool when the EC2 instance stops. So if you stop the EC2 instance and start it again, it will almost always get a different public IP address. And public IP addresses by default are just temporarily allocated for EC2 instances. That's a really important thing to know as things change.
Okay.
So what have we looked at in this video? We've looked at AWS's virtual private cloud, your private network inside AWS's global network. Within that VPC, you get to choose the IP address range that you want for this VPC, and I think of it being like a data center. Inside that VPC, we have a series of subnets. Each of those draws from the VPC's IP address range and then gets access to the internet, either directly through the internet gateway, because the route table controls it to the internet gateway, or to a NAT gateway that you've chosen to provision into one of those public subnets. Public subnets route to the internet gateway and allow both inbound and outbound connectivity. Private subnets can use a NAT gateway to get to the internet, but don't have any inbound connectivity. They're nice and secure. So that's the very basics of VPC networking. Jeffrey, anything strike you about this?
It is very intricate. It's fairly straightforward. Setting up how you set up the subnets and for your public cloud and your private cloud, and setting up the gateway, super easy. It's from there. The routing tables, you just have to understand the range that you want to set it to begin with. Otherwise, you're going to have to destroy that whole segment and bring it back in with the right numbers. And so a little bit of pre-planning is very important in setting up your VPC. So, but other than that, I get the general idea. I'll probably have to watch this about 2 or 3 times before it really sinks in, of course. So, but that's the beauty of recording. What I suggest,
Jeffrey, is that watch the next video as well, because in the next video in this, I'm going to build this actually in the AWS console. And personally, I find that building it and seeing the user interface and putting it together solidifies the theoretical knowledge.
And that's the first episode. Check out the next one as we go into the software and put a VPC together.